Hello everyone, it's me Mithin. Hope you all are doing great. Today we are going to discuss a famous important problem in Java, which is function. The problem is basically find the unique quadruples in an array, add up to the specific target number. So let's dive into the problem. Here we have the problem statement. Given an array nums of n integers, return an integer of all unique quadruples num of a, comma num of b, num of c, num of d such that 0 less than a, comma b, comma c, comma d less than n. A, b, c and d are distinct. Num of a plus num of b plus num of c plus num of d equal to target. You may return the answer in any order. There is an example here. The num array have 1, 0, minus 1, 0, minus 2, 2, and the target number is 0. So here is the quadruples of minus 2, minus 1, 1, 2 in this array. So the sum of this answer is equal to 0. We want to find the unique quadruples in this array. That's the main thing in our this problem statement. And here is another example. Example number 2. Input numbers all 2 to 2, then target is 8. Then there is possibility of one unique quadruples. It's 2, 2, 2, 2. So sum equal to target. So we want all the unique quadruples. So coming to the brute force approach, we want to iterate all over the array. All over means we want to find the all unique quadruples for different loop for getting the 4 different quadruples. So after getting quadruples, there is a possibility of duplications in the quadruples. So we want to use a hash set, right? Yes, because we want to avoid the duplicate elements from the quadruples list. We must want to use the hash set. So I have the brute force solution. I will share with you. Here we can see that we want to iterate all the possible ways for I equal to 0, I equal to 0, j equal to I plus 1, k equal to j plus 1 and l equal to k plus 1. Then we are initializing the sum value. And we are adding the all elements AFI, AFJ, AFK and AFL, and we are checking the condition sum equal to b. B means the target value. If the sum value equal to target sum, then we are adding to the set. If here answer is a set and we are adding to it. In this part we are actually converting the number to string and adding to this set. That's we are doing here. And coming to the time complexity and space complexity of the solution, we are using the 4 iterations, so the time complexity must be of n raised to 4. And space complexity, we are using a hash set, so the space complexity becomes S of n. Time complexity of the solution is inefficient, so we must want to try to think of an alternative approach for getting the efficient approach. Then thinking about the alternative approach, we can use a hash map. Before using hash map, I will just explain how it's work. Before using hash map, I will just give an introduction to hash map. Hash map is a key value concept, so we can easily search the elements in the hash map with the help of the key value there. That's it.
As per the question, sum of distinct integer from the array is equal to 4 distinct integer from the array equal to target. Then the second equation, it's showing that the difference from the 3 distinct integer from target is equal to the 4th element of quadruple.
Now the problem is reduced to find an element A of L in the map. So we can do that. So I have the solution. I will share with you and give an explanation. Okay. This is the for each loop here we are using. In this part, we are adding the elements. We are adding the elements in the hash map. So consider this is our array. Then I have a hash map.
Here key is the values in array. Then Value is the number of frequency of elements in that array.
Frequency hash map here. This thing actually doing here, and this is the function getOdefault. It's actually giving if the value is present in the hash map, then it will increase the value. Otherwise, it gives 0. Also, we want iterate all the possibilities of I, J, K. So, finding this I, J, K, we are finding the element int element equal to b. B is our target, and a of I minus a of j minus a of k. It's actually what element? If the element present in that array or hash map, then it should be a of I, a of x, sorry, a of x. This is the concept. So we are checking key value of element contained, and this thing actually we are avoiding the condition. If the element is equal to less than 0 or 0, we don't want to take the element. For example, the array we are initially take I value, j value, and k value. So we should decrementing the value of count in the hash map. So initially the -1 of value becomes 0, and 5 becomes 0, 2 becomes 0. We're considering the target b equal to 7. So initially we are already take the count ijk, then it should be -1, 5, and 2. Then the value become 7 minus 5 minus 2. Then the total answer become this become equal to 1. So the b element is equal to 1. So we want to find b in the hash map. So here we have 1 in the hash map. So we are so 1 in the hash map. So we are just changing that element to string and adding to the hash set. In hash set, the hash set which will add only unique elements. What we are checking iterating our possibility. Then after coming that, if we want to iterate every next element, we want to increment the hash map count. Count means previously we took the one element and we reduced the count. After changing to one element to another element, then we must want to increase the count, because we are lefting that previous element. So we are adding that element into the hash map. So we are adding here. So finally, we this way we can get the answer. This is one of the approach. And what about the time complexity and space complexity of this solution? The time complexity is equal to O of n cube. Why? Because we are initially considering the three iterations. So it's become time complexity of n cube. And what is space complexity? Space complexity actually O of n plus O of n. How? It's O of n plus O of n. O of n is actually we are using the hash set, and O of m equal to using the hash map. So h plus hash map. That's it about the time complexity and space complexity. What's about the time complexity of O of n cube and space complexity of O of n plus O of m? Is it efficient? Can we improve the solution a little bit to improve our time complexity of O of n square and space complexity of O of n? Is it possible? Yeah, it's possible using two-pointer approach. And I'm discussing the second part of the foursome solution in the next video. So thank you guys for watching the video. Have a nice day. See you again.